Hello everyone, I am Anushka Srivastav. Welcome back to my channel. So today I am here to discuss some of my internal questions. So let's get started. My first question is how unstructured data are analyzed. Give example of data mining activity to analyze unstructured text data. So what do we understand by unstructured data? Unstructured data is information that does not have any predefined format or organization, making it difficult to analyze using traditional data processing methods. Example include text documents, emails, social media posts, images, and videos. Unstructured data like text complaint can be analyzed using various data mining techniques. One effective way to analyze data and convert it from unstructured to structured data is text mining. For example, consider a company that received numerous complaints through email. To analyze this unstructured text data, the following steps can be employed. Our first step is data collection. In data collection, we gather all the customer complaints into a centralized database. Ensure that the data stored is in a format that allows for easy access and processing. Step number 2, data processing. In data preprocessing, there are majorly three steps: data cleaning, normalization, and tokenization. What do we understand by data cleaning? In data cleaning, we remove all the irrelevant information such as signature, disclaimer, and any other textual element. Normalization is a process of converting all the text to lowercase, removing punctuations, and eliminating stop words. Tokenization. In tokenization, we break down the clean text into individual words or token for analysis. Our third step is text analysis techniques. Sentimental analysis. Use natural language processing techniques to determine the sentiment of each complaint. This helps in understanding the customer's emotion and satisfaction level. Topic modeling. In this, we apply algorithms like LDA to identify the common themes or topics within the complaint. This can reveal recurring issues that need to be addressed. Clustering. Clustering is a group of similar complaints to identify the pattern in trend. For instance, complaint about a specific product defect can be clustered to highlight a widespread issue. Our fourth step is visualization and reporting. Use data visualization tool to create a chart or a graph that represent the finding from analysis. For example, a bar chart showing the number of complaints by sentiments or word clouds highlighting frequently mentioned terms. Our fifth and the last step is actionable insight. Based on the analysis, the company can take proactive measures to address the identified issues such as improving product quality, enhancing customer service, and adjusting marketing strategies. Our second question is how text mining techniques can automate the process of classifying written complaints. To automate the classification of written complaints using text mining techniques, you can follow these general steps. Step number 1 will be data collection. Gather a data set of written complaints, ensuring it includes various categories for classification. Step number 2, data preprocessing. Clean the text data by removing noise such as punctuation and stop words, and perform tokenization to break the text into individual words and phrases. Step number 3 is feature extraction. Convert the clean text into a numeric format that machine learning algorithms can understand. Common methods include bag of words, TF, and IDF. Step number 4 will be model selection. Choose appropriate machine learning algorithms for classification. Some popular choices are logistic regression, support vector machines, naive-Bayes classification, random forest. Step number 5, training the model. Split the dataset into training and testing set. Train the selected model on the training data to learn the patterns associated with each complaint category. Step number 6, model evaluation. Assess the model's performance using metrics such as accuracy, precision, recall, and F1 score. This determines how well the model classifies complaints. Step number 7, deployment. Once the model is trained and evaluated, deploy it to classify new incoming complaints automatically. This can be integrated into customer support system for real-time processing. Step number 8, continuous improvement. Regularly update the model with new data and feedback to improve its accuracy and adapt the changing complaint patterns. Question number 3. Consider the following complaint. Suggest the approach, process and algorithm to identify applicable BNS section or IPC section. So this is our complaint. Theft my phone by an unknown person at MG Road on 2023 February 20. The phone was stolen when I was shopping at store. The thief was wearing black jacket and had a scar on his face. Answer. To classify complaint related to theft and recommend appropriate IPC or BNS section using text mining techniques, you can follow this structured approach. Number 1. Data collection. Compile a dataset of complaints specially related to theft, including description and any associated metadata. Step number 2. Text preprocessing. Clean the complaint text by removing irrelevant information, tokenization, and normalization. Step number 3. Keywords identification. Identify keywords and phrases relevant to theft, such as theft, stolen, mobile phone, unknown, black jacket, scar on face. Step number 4 will be feature extraction. Convert the processed text into numerical format using techniques like bag of words, NTF, IDF. Step number 5 is rule-based classification. Develop a set of rules to classify the complaint based on identified keywords and phrases. For example, if the complaint contains theft or mobile phone, classify it under theft-related IPC sections. Step number 6. Mapping to IPC or BNS section. Create a mapping of keywords to relevant IPC or BNS section. For instance, IPC section 378 for theft, IPC section 379 punishment for theft, BNS section related to theft offense. Step number 7. Machine learning models. If a more sophisticated approach is needed, train the machine learning model using labeled data to predict IPC or BNS section based on a complaint text. This involves selection algorithms like decision tree or naive Bayes, training the model on this dataset of previously complaint classified. Step number 8. Evaluation and testing. Assess the accuracy of the classification process by comparing predicted section against a validation set of complaints. Use metrics such as precision and recall. Step number 9. Deployment. Implement the classification system in a real-time environment to automatically recommend IPC or BNS section for any new complaints. Step number 10. Feedback loop. Continuously gather feedback on the accuracy of recommendation and refine the models or rules as necessary to improve performance. By following this structured approach, you can effectively identify and recommend applicable IPC and BNS section for complaints related to theft. Question number 4. Suggest suitable data structure and algorithms for question number 3. The process of mapping unstructured complaints to their respective legal section involves several detailed steps. Let's break it down further with an example and explain how these classifications work. Step-by-step approaches are being followed. Step number 1. Text preprocessing. Clean the complaint text to standardize it for analysis. Convert all the text into lowercase. Ensure case insensitivity. Remove special characters, punctuations, and numbers unless they are relevant. Tokenize the text. That means split the text into individual words or tokens. Remove stop words such as like, is, the, and was. Limitize or stem words. Reduce words to their root format. That means stolen can be converted into steal. Step number 2. Features extraction. Transform the pre-processed text into numerical vectors or representation that machine learning model can use. In this, we can use two processes or methods. They are TF-IDF, that is term frequency inverse document frequency, and number 2, word embedding. Step number 3 is text classification model. Train a supervised learning model using labeled data where complaints are already mapped to IPC or BNS sections. Algorithms that can be applied are naive-Bayes classification, random forest or decision tree, and deep learning. Steps for training are input, pre-processed text and the corresponding legal sections label. Output, a trained classifier that can predict legal sections for new complaint. Our step number 4 is output and recommendation. Our step number 5 is to analyze and recommend IPC or BNS sections. Step number 1. text preprocessing, features extraction, classifications, and recommendations. Step number 6 is suitable data structure and algorithms for classifying complaints. Data structures that are involved are dictionaries or hash maps, graphs, and sparse matrix. Algorithms that can be applied are naive-based classification and decision tree. Our step number 7 is ensuring accurate categorization into legal sections. Train model on comprehensive data steps containing diverse examples of complaints. Use cross-validation to avoid overfitting. Employ hierarchical classification if legal categories have subcategories. Step number 8 is metrics for assessing text mining performance. Precision, recall, F1 score, and confusion metrics. Step number 9 is effectiveness and evaluation of text mining. Effectiveness means text mining improves accuracy by identifying patterns and keywords into unstructured data. Advanced model like BERT can understand contextual relationships in text. Evaluation. Compare metrics. Use confusion metrics to identify common misclassification. By systematically applying these techniques, unstructured complaints can be effectively classified into a correct legal categories. Question number 5. Explain suitable metrics to assess the performance of algorithm in text mining. To assess the performance of algorithm in text mining, several metrics can be utilized depending on the specific task. Here are some key metrics. Number 1. Accuracy. The ratio of correctly predicted instance to the total instance. It's a straightforward measure of overall performance but can be misleading in imbalanced dataset. Precision. This matrix evaluates the accuracy of positive predictions. It is defined as the number of true positive divided by the sum of true positive and false positive. High precision indicates that the model has low false positive rate. Number 3. Recall. Sensitivity. Recall measures the ability of a model to find all relevant cases. It is calculated as the number of true positive divided by the sum of true positive and false negative. High recall indicates that the model is effective at identifying positive instance. Number 4. F1 score. The F1 score is the harmonic mean of precision and recall. It provides a balance between the two metrics and is particularly useful in scenarios where there is an uneven class distribution. Number 5. Confusion matrix. This is a table that allows visualization of the performance of the classification algorithm. It shows the true positive, false positive, true negative, false negative, providing insight into the type of errors made by the model. Number 6. BLEU score. Primarily used in machine translation, the BLEU score measures the overlap of n-grams between the generated text and the reference text. It ranges from 0 to 1, with higher score indicating better quality. Number 7. RUG score. Similarly to BLEU, RUG measures the overlap of n-gram but focuses on recall. It is often used in summarization tasks to evaluate how much of the reference text is captured by the generated output. Number 8. Meteor score. This matrix improves upon BLEU by allowing for synonyms and stemmings, making it more flexible in evaluating generated code quality, especially in machine translation. Number 9. Perplexity. Used to evaluate language model, perplexity measures how well a probability distribution predicts a sample. Lower perplexity indicates better performance. Number 10. Area under the ROC curve. This metric evaluates the performance of a binary classifier by plotting the true positive rate against the false positive rate at various threshold settings. A higher AUC indicates better model performance. Number 11. Mean squared errors. For regression tasks, MSE measures the average of the square of errors. That is the average squared difference between the estimated value and actual value. Number 12. Mean absolute error. Another regression medley Another regression matrix, MAE measures the average magnitude of the error in a set of predictions without considering their direction. It is the average over the test sample of the absolute difference between prediction and actual observation. Here we complete our first internal questions. Stay tuned for further lecture. Thank you.